All right, so today I will be doing a walkthrough of our IMG 420 final project, and this project revolved around creating a GD extension for Godot. And what we chose to do was create uh, a module or a node that we call DistortionSprite2D. And what this allows developers to do is easily procedurally just distort and animate sprites. So dynamic animation, essentially. That's very easy for developers to implement. So what I'll start with is showing you some of our code that's actually in the source of the extension. So DistortionSprite2D.cpp. We just start up here by binding our methods and then exposing all editable properties to the editor. And then we use the way that this all works is we split the sprite into a grid, and the vertices of that grid we move around and apply impulses to dynamically animate the sprite. And so part of that is we have ambient noise built in through the use of Perlin noise. And so this is a Perlin permutation table to work in favor of that. Then we have some property setters to set the grid size. So however many divisions you want the grid split into, obviously, more divisions is more vertices, so that's more intense, but the animation looks smoother. And then set texture to apply your custom texture. So then here we have some distortion interactions, and these are the functions that are exposed to the developer. So apply impulse, you can set a position and a force to apply to a specific point on the texture. And then it will apply a splash radius that diffuses the further out from that point that you get. And then if you just want to reset all of the vertices to their original position and set their velocities to 0, you can do that with reset mesh. Then we have build grid here. And here are Perlin noise functions that handle just ambient noise to make things wobble or shake. Then down here is our big function, and this involves redrawing the mesh. So this happens every frame, essentially, because we need to move the vertices and then redraw the actual texture around those new vertice positions. And so within each of those squares that are created by the vertices, we split it into 2 triangles, and that helps us dynamically animate the sprite. And then you can see it here. We have our DistortionSprite2D, and you can mess with some of these exposed editable properties like elasticity, damping, noise amplitude, speed, the grid size, and then you can apply your texture. And then in the code, you can call actual functions to reset the mesh and then apply impulses, right? So right here we have apply clamped impulse, and that just makes sure that the impulse stays within a defined range of how powerful it should be. So I'll boot up the game here and then show you some of these things in action. Right here, these buttons are DistortionSprite2Ds, and they are just using ambient Perlin noise to move around and wobble. Our slime character's also using Perlin noise to just ambiently shake. And also, you can see that when we move, that applies an impulse to him to make him distort even more. And that is where the apply clamped impulse function that you just saw is used. So it gives us it makes the slime feel alive, like it's reacting to the force of your inputs. Now this water down here is also a distortion sprite, and you saw how it reacted to the slime jumping in. Wherever the slime collides with the water, we apply an impulse, and that's what makes the water jump up and look like that sort of splash effect. And so it's very easy to do because really you're not animating that at all. It's a dynamic animation that happens in real time. And so it's very easy for developers to implement. But those are the major points. So now let's talk about some of our challenges. The main one that I ran into was when animating the slime, I wanted it to have a slight wobble, but since it was being applied every physics frame and compounding the impact force, the slime was having extreme wobble and shake, which did not look how we wanted. So we created a function called apply clamped impulse, which made sure that the impulse force stayed within a defined range. But one interesting thing about that is that we found out that the extreme distortion is good for cloth physics. It looks like very believable cloth physics in the wind, and it can react to other impulses as well. So yeah, that's our extension.